You are across the line, not falling toward it, not approaching it, across it. The event horizon of a supermassive black hole, an object 4 billion times the mass of our sun, the kind that anchors an entire galaxy at its center, is behind you now. You crossed it a second ago, maybe less, and nothing happened. That is the first thing, the most disorienting thing, the thing that every instant you have screams, cannot be right. You crossed the most consequential boundary in the known universe, the threshold beyond which nothing, not light, not information, not any force or signal or prayer can ever return, and you felt nothing. No wall, no flash, no alarm, no physical sensation of any kind that distinguished the inside from the outside. 1 second ago, you were in the universe. Now you are in something else, and the clock is running. Not metaphorically, there is a real, physical, calculable amount of time between the moment you cross the horizon and the moment you reach the singularity. That time is finite. It is determined by the mass of the black hole and the physics of curved space-time. For a 4 billion solar mass black hole, that time is approximately 14 hours of proper time. Time is experienced by you, measured by a clock you carry, felt by your body as the normal passage of moments. 14 hours. That is how long you have. And what happens during those 14 hours is unlike anything the human nervous system has ever been designed to process. Measured. First, the sky. Look up. Look in every direction. The universe is still visible from inside a black hole. Light from outside can cross the event horizon inward. Only outward travel is forbidden. So the stars, the galaxies, the faint background glow of the cosmic microwave background, all of it is still reaching your eyes. But it looks wrong. Light falling inward toward the singularity is blue-shifted, compressed to shorter wavelengths, higher energies as it descends deeper into the gravitational well. The stars appear bluer, brighter, more intense than they did from outside. The entire visible universe appears compressed into a circle above you, a bright, concentrated disk of all the light from all of history squeezed into a shrinking window overhead as the geometry of space-time channels inward-falling light into an increasingly narrow cone. This is called the aberration of light. As you fall deeper, the window of sky visible above you shrinks, the angle of the cone narrows, stars that were spread across your entire field of view compress toward a single point directly above, the direction from which you entered, the direction toward the horizon, the direction you can never return to. The universe is still there. It is retreating from you, geometrically, in a way that no amount of thrust could reverse. And below you, if below means anything in this geometry, is darkness. Not the darkness of empty space, which is filled with faint radiation in distant galaxies. A different darkness. The darkness of a region where no light originates, where the singularity lies, where the future resides. You are falling toward the dark. The universe is compressed into a circle of light above you, getting smaller with every passing second. 1 minute in, your instruments are reading normally. Your body feels normal. You are in free fall, which is weightless, which feels exactly like floating in space always felt. There is no sensation of the extreme curvature of space-time around you. General relativity's equivalence principle guarantees this. Free fall in curved spacetime is locally indistinguishable from inertial motion in flat spacetime. Your vestibular system has no mechanism to detect spacetime curvature. But your instruments are detecting something. The tidal forces, the difference in gravitational pull between the near side and far side of your body, are measurable, though not yet dangerous. For a 4 billion solar mass black hole, the tidal forces at the event horizon are gentle enough that you crossed without noticing, but they are increasing, slowly. Every meter closer to the singularity, every second of falling, the gradient grows. 1 hour in, the circle of sky above you has shrunken noticeably. What was the entire hemisphere of the visible universe, 180 degrees of sky, everything above the horizon, is now perhaps 60 degrees across. A disk of compressed starlight, still bright, still containing every galaxy that ever emitted a photon that reached this black hole, but smaller. And the light from that disk is changing. photons falling inward alongside you, light that entered the black hole at roughly the same moment you did, from the same region of sky, are arriving at your eyes having traveled similar distances. But photons that entered later, from directions increasingly off-axis, have had to curve more strongly. Their paths are more extreme. The later they entered and the more extreme their path, the more blue-shifted they appear. The disk above you is not uniformly bright. Its edge is a ring of increasingly intense, increasingly blue light, a bright annulus around the shrinking window of the universe, glowing more and more fiercely as the geometry squeezes more and more of the outside universe's light into a smaller and smaller solid angle. It is beautiful in a way that has no earthly equivalent. The entire cosmos, every star and galaxy that has ever emitted a photon that reached this black hole, concentrated into a single shrinking circle of blue-white light above you, while below stretches absolute darkness. You are at the center of something, not comfortable, not safe, but geometrically precise in a way that feels almost deliberate. The singularity is 8 hours away.
4 hours in. The disk has shrunk to approximately 30 degrees, the apparent width of your outstretched hand at arm's length. The ring at its edge is hot. If you could measure the temperature of the radiation arriving at your eyes from the compressed sky, it would be higher than it appeared from outside. The blue shift is carrying the entire spectrum upward, pushing infrared photons into visible light, pushing visible light toward ultraviolet, pushing ultraviolet toward X-rays. The universe is irradiating you. Not lethally, not yet. For a 4 billion solar mass black hole at 4 hours of descent, the flux is elevated but survivable for a body protected by a pressure suit designed for space. But it is increasing. Everything is increasing. The tidal forces, the radiation, the compression of the sky, the darkness below. You have been falling for 4 hours and covered a distance in coordinate terms that would make sense from outside, that is difficult to express in a way that connects to any human scale. You are deeper inside the event horizon than any object has ever fallen and returned information, deeper than any probe has ever reached, deeper than any theory has ever been tested against direct observation. You are in a region of space-time that no physics experiment has ever accessed. The equations extend to this point, the mathematics continues, the predictions can be made, but no measurement has ever confirmed them here. You are, in the most literal sense, in unexplored territory. 8 hours in. The disk above you is a small, bright circle, perhaps 15 degrees across, roughly the apparent width of your fist at arm's length. Its edge blazes. The radiation arriving from it is now definitely in the X-ray range for a significant fraction of the photons. Your suit is absorbing dose. And something else has changed. The tidal forces are no longer measurable by instruments. You can feel them. Not painfully, not yet with the dramatic stretching that the word spaghettification implies, but a subtle sense at the limits of human perception, the kind of sensation that might be dismissed as imagination if you did not know exactly what was producing it, that your feet are being pulled very slightly more strongly than your head, an almost imperceptible elongation. The singularity is 6 hours away. And here is the thing that the physics forces you to confront, the thing that no adjustment of trajectory or application of thrust can change. Those 6 hours are not optional. The singularity is not a place you are heading toward by choice. It is a moment in time you are heading toward by the same mechanism that carries you from now into the future. You cannot turn away from the future. 11 hours in. The disk is a small, brilliant point almost directly overhead. The ring has become so intense that looking at it directly is impossible. The radiation pressure from concentrated blue-shifted photons would damage unprotected eyes in seconds. Your suit's visor has darkened to its maximum opacity and is still registering elevated flux. And something else has changed. The tidal forces are no longer subtle. The differential between the gravitational pull on your feet and your head, you are falling feet first, the instinctive orientation of a body anticipating impact, is now measurable in terms you can feel as physical sensation. Not the stretching of spaghettification, not yet, but a persistent, increasing sense of being pulled apart along your long axis while simultaneously compressed from the sides. Your instruments are still functioning. The readings they produce are still interpretable by the physics you were trained in. But the physics you were trained in is approaching its boundary. The singularity is 3 hours away. 13 hours in. This is where description begins to fail. Not because of a shortage of words, because the physics that provides the basis for description, the framework of cause and effect, of measurable quantities, of a space-time in which coordinates can be assigned to events and distances can be calculated between them, is approaching the region where it stops providing reliable guidance. The tidal forces are severe, the radiation is extreme, the circle of sky above you has compressed to a point, not a disk, not a circle, a point of light. The entire observable universe collapsed into a single bright spot by the extreme aberration of the infalling geometry. You are seeing all of the history of the universe's light emission, every photon that has ever crossed this black hole's event horizon, compressed into a single point directly above you. One point of light, above infinite darkness, below, and you falling between them, in a space-time that the equations extend through, but the measurements have never confirmed. The singularity is 1 hour away.
Here is what the physics says next. And here is where the physics admits it does not know. The equations of general relativity extend to the singularity and produce there a prediction of infinite density and infinite curvature. The tidal forces approach infinity. The distinction between before and after, the temporal dimension that has carried you this far, reaches its terminus. In classical general relativity, the singularity is the end of spacetime. Not the end of your journey through spacetime, the end of spacetime itself at that point. The question, what happens next, has no answer, because next requires a spacetime to exist in, and the singularity is where spacetime stops. But classical general relativity is an incomplete theory. It does not incorporate quantum mechanics. At the extreme densities near the singularity, densities that exceed anything nuclear physics can describe, approaching the Planck density where quantum gravitational effects must be dominant, the equations of general relativity are no longer reliable. What happens at the singularity is the question that quantum gravity was built to answer, and quantum gravity is not finished. String theory, loop quantum gravity, causal dynamical triangulations, each of these frameworks makes different predictions about what replaces the singularity when quantum effects are accounted for. A bounce in some models, the collapsing matter reaching maximum density and expanding into a new region of spacetime, a new universe born from the singularity, as Poplawski's models suggest. A quantum foam of spacetime geometry fluctuating at the Planck scale in others, something else entirely in frameworks not yet developed. The honest answer is, we do not know what you encounter at the singularity. We know you cannot avoid it. We do not know what it is. Here is the question that the information paradox asks on your behalf. You fell in. You carried information, the quantum state of every particle that makes up your body, the complete specification of everything you are at the quantum mechanical level. That information crossed the event horizon. It cannot escape. When the black hole eventually evaporates through Hawking radiation over timescales that dwarf the current age of the universe, the radiation that escapes carries, according to quantum mechanics, no information about what fell in. Your quantum state does not appear in the Hawking radiation. It is gone. Or is it?
The information paradox is the deepest unsolved problem at the intersection of general relativity and quantum mechanics. Its resolution, when it comes, will require a framework that correctly describes both simultaneously, exactly the framework we do not yet have. In some proposed resolutions, your information is preserved, encoded in subtle correlations in the Hawking radiation, in soft photons on the horizon, in entanglement structures that classical physics cannot describe, but quantum gravity eventually will. In others, information is genuinely lost, and the universe is a place where some things can be permanently destroyed. What you are, in the quantum mechanical sense, the information that constitutes you, is either somewhere we can currently access or nowhere at all. Physics cannot tell you which. Let's come back to the first second. You crossed the event horizon. Nothing happened. No sensation, no alarm, no physical experience that distinguished the inside from the outside. And yet everything had changed. The singularity was now in your future, unavoidably, permanently. 14 hours of proper time ahead of you, as certain as tomorrow, as inescapable as the direction of time itself. You had entered a region of space-time from which no information would ever return. Whatever you experienced from that point, whatever the 14 hours contained, whatever the singularity was, would never be communicated to anything outside. No signal, no record, no description transmitted back to any observer in the external universe. You would know what happened, and then you would reach the singularity. And the question of whether knowing at that point means anything, whether the information that constitutes you persists in any form, whether there is any sense in which experience continues past the point where space-time ends, is the question that the greatest minds in theoretical physics have been working on for decades and have not answered. The event horizon is not a wall. It is a point of no return defined by geometry. A mathematical boundary in space-time where the direction you cannot travel, outward, back toward the universe, is not blocked by any force or object, but simply becomes the past, becomes the direction you cannot go, because that direction is behind you in time. Inside a black hole, you do not feel trapped. You feel normal, until the tidal forces begin. Until the radiation builds, until the circle of sky above you compresses to a point, until the singularity, whatever it is, becomes 1 hour away, then 30 minutes, then seconds. You feel normal until you don't, and by then, no amount of feeling otherwise changes anything. The universe outside continues. The Hawking radiation continues its slow bleed of energy from the event horizon. The black hole continues its billion-year drift toward eventual evaporation. The galaxies outside continue their rotation around the massive object at their centers. All of it continues, without any record of what happened inside, without any signal from the 14 hours between crossing and singularity, without any answer to the question of what you found at the end. The black hole keeps its interior the way the universe keeps its oldest secrets, completely, permanently, and without the slightest indication that anything worth knowing is being kept at all.